Welcome, everybody. It's time for our first 2017 AWRA webinar. This is Michael Campana, your moderator, coming to you live from rainy, chilly, actually not too chilly, Corvallis, Oregon, and hoping that those of you who are watching have some sunshine somewhere. We've got a great one today, and I know I say that a lot, but this is really super. John Fleck, who is by now a household word, at least west of the Mississippi, will be treating us to a presentation on his book, Water is for Fighting Over, and Other Myths About Water in the West. And we've got a huge audience for this one. I won't tell you what the numbers are, but it broke my record, so but I'm happy about that. I also want to thank our hosts, Montgomery or MWH Global. You can see the logos down there. And I've also added the Stantec logo because MWH is becoming a part of Stantec, and I think the merger takes place in the official merger in a couple of months. So I just want to thank MWH and the folks in Sacramento for being so kind and letting us use their we also have a special deal for you. Thanks to Matt Solomon and the folks at Island Press. You can save money. You want to buy John's book because John's only going to be talking for about 40 minutes, and the book is just chock full of wonderful stories and information. You can get this for 30% off, and so if you go to the URL that I have there and purchase the book, and right when you go to checkout, there'll be a place where you can enter a code, and if you just enter AWRA, the discount is actually automatically taken care of. And it actually does work because I bought another copy. So some tips participating in the webinar. Again, we urge you to ask questions. The questions, you will use your little chat box over on your panel, and so you'll punch in your question. It'll come to Christine and me, and then we'll ask the questions of John when he's done at the end of the webinar, approximately 15 minutes before the hour. And we do have the capability to go past the witching hour and maybe add 10 or 15 minutes on. We don't like to go too much longer than that asking questions because people start to drop off pretty quickly. So we don't have to, we don't turn into pumpkins at that hour. So ask a question, and please try to be concise. And when you have your the webinars done, about a week or so, we'll put it up on the website. You can access the archive, but the caveat is you do need a Dropbox account to see the entire recording. So those are free. You'll have to have one. This is the schedule. It's pretty simple. I'm doing the introduction. We have John. He'll speak for about 40-45 minutes, and then we'll go to the questions. And now we get down to here he is. This is John Fleck in his famous Colorado River hat there. He's actually on the banks of the Colorado. He's on the Mexican side, and that is Morelos Dam behind him. I've known John for a number of years. He's now director of the Water Resources Program at the University of New Mexico. For many years before that, he was a really super journalist for the Albuquerque Journal, the largest daily newspaper in New Mexico. He was the water and environment guy, and he built a reputation for real solid reporting, getting the facts. And he's also run a very well-known blog, John J. Fleck at Inkstain, for I think about 12 or 13 years. John, you were at it before I was, and some of the most perceptive stuff I've seen about water is on John's blog, so I'd encourage you to take a look at it. And then that's me. Okay, you know who I am. I'm still technical director. There's Christine. She's the master controller sitting back there in Middleburg, Virginia, and she can do whatever she wants with things. Suggestions, we've got webinars set up through June. So if you still have any ideas, you can send me an email, aqueduct@awra.org, and you can actually look to see what webinars we have coming up. And in the minute I have left, let me just show you what's coming up next. We're going back to the east. Lara Fowler, Beth Kinney, and Matthew Draper be talking about climate change and water management in the east. Then in March, Molly Wood of the USGS on World Water Day will tell us about innovations in sediment monitoring. And then the next couple ones, I don't know who got these next two in here. It's about ground. No idea who did that. Bill Alley and Rose Marie Alley, the great husband and wife team. That's the title of their new groundwater book, which should be out soon. And so they'll be doing what John's doing today. Then Sharon Megdal, University of Arizona, groundwater. She's the groundwater governance goddess. She's going to be telling us about that. And then finally, we're going back to the Colorado River with Sarah Porterfield from UC Boulder. So if you have any suggestions for things to give us, go ahead. So I'm going to introduce John now. He's just a wonderful guy, very smart, and he's actually a native of Southern California. I think most people don't know that. And he went to school at Whitman College, majored in philosophy, history and philosophy of science, and he's actually been at this a long time, and I just can't say enough about him, so I'm actually going to shut up now and let John take it over. So, sir, I'm going to take it out of here and let you do your thing.
Thank you very much. Just real quickly on that list of upcoming webinars, I highly encourage you to listen to the Alleys, and I had a chance to read their book in Galleys, and I think it's a really important and useful, interesting book, kind of in the genre of the kind of thing I'm trying to do, which is get messages, useful messages about water to a wider sort of crossover audience between technical and water administration and the public. Great book. Really looking forward to its appearance in the public. Thank you much for all coming. Thanks to Michael. And I will point out that as director of the Water Resources Program at the University of New Mexico, which is a relatively new job, I'm quite literally sitting in Michael's old office. He was the director of this program a couple of directors back before me, and I inherited his office. And so it's a proud tradition that I hope to uphold here at the University of New Mexico. Small graduate program, master's degrees in water resource management for future water managers, which is sort of the alternative goal for me now that I'm out of journalism, is how do we get good ideas out into the world to solve problems. I would thank you all for coming and would like to spend a few minutes talking about my book, if that's okay with you all. It's a book that is, in part, offers up what I hope to be sort of a counter-narrative to the traditional doom and gloom stories about water in the West, which are a long-standing tradition and literary tradition that I, imagine myself falling into. My basic message is that we can, in fact, solve our water problems, that we have a good track record, a better track record than we give ourselves credit for here in the southwestern United States, but that to do it, we have to move beyond the sort of rhetoric of doom and failure that has embodied a lot of the literature and the public discourse about this issue. And one of those things that we have to get over is a lot of the myths that I think have plagued discourse about water in the West. And I want to talk about the sort of key things that I point out in the book. My personal story, as Michael mentioned, I grew up in Southern California in a home that was built as a tract home in the 1950s on top of an old citrus grove. Water was kind of at the root of citrus farming in Southern California. Has always been a big part of my life. I worked in Southern California as a journalist covering the Metropolitan Water District of Southern California during the drought of the 1980s, and that was the time when Cadillac Desert first came out. I read that book at the time. It influenced me enormously. It's one of the sort of great works of the nonfiction canon about the history of water in the West. And Cadillac Desert has been a really dominant narrative in our discourse about water in the Western United States. It framed the story around these crazy decisions that we made building an unsustainable system, the dams and the canals, the farms and the cities. And it was also kind of a narrative about greed and villainy. Came out in 1986. And one of my friends who writes about water describes Cadillac Desert this way. She says, Cadillac Desert rendered itself obsolete. And I think that's a really interesting insight because in the years after Cadillac Desert came out, whether through the underlying trends of history or whether because of the influence of the book, we'll never know, we really started changing our behaviors. And things started happening that Cadillac Desert didn't anticipate in terms of conservation and changes in the way we manage our water, and really the sort of adaptive behavior that's really helped us and really improved our situation, but I don't think we give ourselves enough credit for that. And I think giving ourselves credit for that is an important part of succeeding going forward. We have to know that this stuff is possible. First of all, can everybody see now we went to the second slide, greetings from Albuquerque in the upper Colorado River Basin? Is that working?
Yep.
Yes,
it's working,
we can
John.
see it.
Great, great. So, so here in Albuquerque, New Mexico, we are in what is called under the law the upper Colorado River Basin. And that's a weird thing because if you look on that map, you can see a black line highlighting the Colorado River Basin. We're clearly outside of that, kind of over on the right side of the screen, that sort of red hashed striped area along the Rio Grande. But we are one of the communities in the western United States that depends on taking water outside of the Colorado River Basin through trans-mountain diversions, this Rube Goldberg series of tunnels and dams and canals that move water out of the basin to really important communities throughout the western United States, the Front Range of Colorado, Albuquerque, New Mexico, the Santa Fe Albuquerque corridor, and probably most importantly in terms of the number of people who depend on it, Southern California, coastal Southern California from Los Angeles down through San Diego. And if you look at the picture on the left, that is what results out of all these decisions that we have collectively made to move water to farms and cities outside of the river corridor itself. That's my wife's, Lissa's Subaru parked in the bed of the Colorado River underneath the bridge at San Luis in Mexico. You know, this is this great river that is, as Phil Fradkin described it, a river no more. That's a place where there used to be steamboats. And that's a day in March of 2014, you know, the only thing that could drive up and down this riverbed are big, fat, tired vehicles. If I had tried to get any farther up the riverbed in that Subaru, it would have been stuck in the sand. We've taken all that water out of the river, and we've done other things with it. And I think we need to recognize that those are good and valuable things. The city I live in, the city I grew up in, depend on that water. But there has been this price that we have paid in terms of places that water no longer gets and sort of modern values that suggest that maybe that's a problem. In order to overcome that problem, though, we have to get beyond the narrative that looks at that car parked in that sandbed as this sort of inevitable catastrophe that sort of awaits the rest of us as the water supplies shrink. And in order to think well about that, we have to start thinking better about the myths that we've told ourselves about water in the western United States. And one of the most important ones is this notion that we're going to run out of water. And one of the fascinating things that I found in doing the research for my book, I went back through old news clippings, lots and lots and lots of old news clippings, and I found stories like this over and over again. This happens to be from the Los Angeles Times in January of 1960, but this is a thing repeated over and over again. You know, this is a story that says Southern California is going to run out of water in 10 years. That doesn't do anything. I particularly like this one because it was published a few months after I was born in Southern California. Southern California has doubled in population since that time. They haven't run out of water. They're doing okay. It's been difficult throughout, but there have been this series of adaptive behaviors that have allowed them to survive and even thrive with a lot more people, and ultimately, as we'll see later, using less water, and that's a really important thing. And related to that, I want to show this graph from the Bureau of Reclamation's Colorado River Basin study, because this graph has come to embody the sort of notions that we're running out of water. This was published in 2012 in the Basin study, and states from the Colorado River Basin, you know, with their collective wisdom, provided data to the Bureau about how much water they expected to need. And so this isn't the Bureau saying we for sure need this amount of water. This is the Bureau collecting the sort of baseline idea of what the communities in the basin think they might need to help us discuss this as a set of political and policy questions about how to face our future. And you can see in the Colorado River Basin the lines on the left. To the left of that dotted line is the historical period. That blue line is the amount of water the Colorado River supplies. The orange line is our use of water. And you can see those lines crossed, around the late 1990s, early 2000s. And the expectation is that demand will continue to rise. This was the expectation of what the states told the Bureau. And if you look at that blue line beneath it, you can see that supply, and the blue line incorporates some assessments of climate change. Some of the modeling runs that went into that fuzzy line don't incorporate climate change. But generally speaking, a declining supply, a rising demand, and that gap between the two has sort of been perceived, and this graph has been widely used to say we're running out of water, we have this future problem, because that gap between the orange line and the blue line, that's, we can't use negative water, so that's, clearly, that's clearly not possible. I'm going to talk, as we get through my talk here, and then if you have a chance to read the book, I'll talk more about why I think this is a myth, but I want to switch to the second really important myth, and that's the idea that whiskey's for drinking and water's for fighting over, which has been commonly attributed to Mark Twain. There is kind of a parlor game for some of the journalists and water wonks to try to beat this down every time people repeat it. First of all, because Mark Twain didn't say it. There's no evidence that Twain said it, even though it's often attributed to him. But secondly, and I think really importantly, one of the things we find when we look at the history of water in the Colorado River Basin, but also when you look at broader research on water management around the world, and Michael's colleague Aaron Wolf there in Oregon has done a lot of really important work on this. Far more often, water becomes, when there is a transboundary conflict, people trying to share water across a border, states, nations, far more often they end up collaborating and solving their problems in really useful ways rather than fighting over it. So to the extent that people think that gap between the orange line and the blue line means we need to gird ourselves for combat over water, we're heading down a really dangerous path, because it's really important to me, and what I argue in the book, to understand that we actually have developed this history, especially in the Colorado River Basin, of collaborating over water rather than fighting over. And that gap between the orange and the blue lines doesn't mean we have to fight over water. A sort of related myth is what I think is the myth that water flows uphill toward money. And people use this a lot, and there's some different ways, different things that they mean by it. One of the really simple meanings is that wealth allows you to develop the infrastructure you need to bring water, and that's probably true. You look at the Central Arizona project, bringing water from the Colorado River to the Phoenix-Tucson area. Water was flowing uphill because there was a lot of money to bring that water. But a more common use of the phrase water flows uphill toward money is that in these conflicts over water, the rich communities will inevitably, politically and financially roll the poor communities and take their water. And I think that's just, in the western United States, demonstrably wrong, but sets up a really dangerous political dynamic. And my favorite example of this is Las Vegas, Nevada, and Yuma, Arizona. Las Vegas uses 1/3 of the water that Yuma does. Las Vegas is vastly more wealthy than Yuma. They are both drawing from the same water supply, and yet our long history of the doctrine of prior appropriation and the protection of agricultural communities really leaves Las Vegas with absolutely no way to take away Yuma's water. There's no way Yuma's water is going to flow uphill toward Las Vegas money. And this is sort of one concrete example of this broad phenomenon that agricultural communities have been respected in the allocation of water rights, and their water is not easily taken away. And so I think this is another one of these important myths that we have to get beyond, because if you go down to Yuma, they're really scared that the rich people are going to take away their water, and that makes it harder for them to collaborate and cooperate in these water sharing arrangements of the future. One of the things that changes the dynamic dramatically in water use in the United States and really in the rich world, and really makes possible the kind of solutions that I talk about in my book, is the phenomenon of what economists call decoupling. And this is a graph from a 2010 paper by Peter Glick of the Pacific Institute, published in the Proceedings of the National Academy of Science. And the sort of traditional expectation that we're going to run out of water is built on the idea that more people or more economic activity means greater demand for water. Here in the United States, that relationship broke down around 1980, and Glick's data really clearly shows that. We've got that sort of reddish-brown graph, which is economic activity, U.S. GDP, and the blue line is water withdrawals. And around 1980, the two lines separated, and water withdrawals didn't stop growing. And if you extend that line out beyond when the newer data that's available since Peter wrote that paper, the line actually starts bending down, suggesting that our population and our economy continues to grow while our water use is declining. In the book, what I try to do is sort of travel around the West and look at some particular geographies and show what they did and how they did these things that have allowed this decoupling, in fact, to work and work really quite well. Let's start with Las Vegas. One of my favorite interviews was with a landscaper in Las Vegas who told me we do fake well. And Las Vegas is a community that really depends on, for its economic well-being, the impression of lushness, the illusion of lushness. So this is out in front of Treasure Island and Mirage hotels on Las Vegas Strip with the palm trees and the waterfalls and the lakes. But if you look closely, that's a fake lawn, right? So they're really doing fake. They're giving you this green and doing it without water. And if you look at those fountains on the Strip, which create this image of lushness, there's a regulatory system in place in Las Vegas that requires those big hotel casino fountains to use non-potable water. It's water that they couldn't be using for drinking water, et cetera. So let's look at the numbers from Las Vegas. And this is population growth and Colorado River water use in southern Nevada, which is Clark County, Las Vegas, the greater Las Vegas metro area, just sort of scaled so the lines match up. And what you see is population growth and water use. And again, the Colorado River makes up almost all of their water supply, 90% of their water supply. Their use of Colorado River water climbing in lockstep with population, just like that Peter Glick graph. In 1980, their population was 460,000, and in 2014, their population is 2 million. Around 2000, some relatively aggressive policy innovations in terms of conservation, lawn buyback programs, et cetera, really kicked in, and you can see that on the graph. So their water use has been going down. At the same time, their population is growing. This is a community that decided they wanted to pursue the path of development. A lot of people disagree with that, but Las Vegas gets to choose what they want to be as a community. They realized their water supply was constrained, and so they figured out how to do it, how to be the community that they wanted to be in the face of a constrained water supply. Population up, water use down, and they're really an interesting model, but they're not unique. And if you look around the western United States, you see this phenomenon over and over again. All the major metro areas have this same pattern. So if you look at Los Angeles and Southern California, the communities of my birth, look at those palm trees, which are the iconic symbol of Southern California. Those are an ecological cheat, right? Palm trees grew, Palm Springs is named that because the palms grew around the springs. The trees like to have a lot of water, so they grew in the springs up in the mountains. You bring the palms out of those mountain springs and plant them around your city. You got to water them a lot. And so again, this impression of lushness, which was part of what made Southern California a desirable place to be, importing water, spreading water across the land. But again, in Los Angeles, so this is data from the Metropolitan Water District of Southern California, and this is the entire Met service area. The graphs are a little more subtle, but the same thing is going on. Around 1990, big drought, super conservation, that big drop there. But then water use and population kind of decouple. It's a little more subtle in the graph, but the same thing is happening. Population is rising, water use is going down. It appears that the drop in water use has continued as they've aggressively responded to the drought. So again, another success story. one more of these success stories. This is my own. This is the one that really convinced me that the old Cadillac Desert narrative that I was pursuing was wrong. This is New Mexico's Rio Grande, and the graph there is flow on the Rio Grande, native water in the Rio Grande at Ottawa, which is one of the main measurement points in central New Mexico. And the thing to look at here is the sort of reddish line is the mean, the average over time going back to the 1940s, and the black lines are the annual flow. And you know, look at the 21st century, those last 15 or 16 years, only 2 years have been above the long-term average. That is by any definition a drought. We talk a lot about what the definition of drought is, but that clearly having 14 out of 16 years below average is a drought. And yet, during that time, the farmers who depend on water in the stretch of the middle Rio Grande have gotten full supplies most years. If you look at their productivity in terms of agricultural productivity, the economic productivity of these farms, not really affected by the drought. And the thing that's happened in the farm sector is they become much more efficient with their irrigation in response to drought. They've adapted to having less water. And if you look at the cities, and this is really an interesting phenomenon to me, and I've got a new graduate student looking much more closely at these numbers. That's my aquifer beneath, like literally beneath my house. There's a groundwater measurement well near my house. The city of Albuquerque has had a very successful conservation program. It also has shifted from pumping groundwater to using imported surface water from the Colorado River Basin. And those two things combined have led the aquifer to recover about 15, 20 feet around the city, so that Albuquerque, in the midst of, the biggest city in this region, in the midst of a significant long-term drought, has seen its aquifer rebounding. And that's, a really important success story. Albuquerque decided that it could no longer depend on overpumping and mining its aquifer, has shifted its behaviors and its sources of supply, and has seen its aquifer recover. So, in the midst of 16 years of drought, successful adaptation seems to be going on here in this community. We don't seem to be heading for the kind of doom that the traditional Cadillac Desert narrative implied. I'm not cherry picking. You see this all over the place. The fountains of, that's the top left is a place called Fountain Hills in Arizona, this crazy community, water using community with this giant fountain. And, Arizona has chosen to use its water in this particular way. Water use in Arizona decoupled again. This is total water use in Arizona compared to population. Water use peaked around 1980, according to the U.S. Geological Survey data, has been kind of bending downward. The curve's been bending downward while population has grown dramatically. So again, and what you have is regulatory innovations. What you have is imported water, although that water use line includes their imported water. So regulatory innovations have reduced their groundwater pumping. The drop in groundwater pumping is greater than the increase in imported water. So they didn't just import water and continue to pump groundwater. They cut their groundwater pumping by a comparable amount. But we should also remember, and this is really important in the public discourse about water, that a significant fraction of the water, probably 70, 80%, depending on where you are, of the water withdrawn from rivers and groundwater for human use, is used by agriculture. So let's look a little bit at the agricultural sector. And one of the most interesting places for me as a person writing about the Colorado River Basin is the Imperial Valley of California. It's down in southeastern California, that kind of red-hatched blob around the Salton Sea, just outside of the basin. It's the largest single irrigation district in the Colorado River Basin, one of the largest in the nation. Upwards of 400,000 acres of irrigated agriculture. Money farming. This is not, sort of backyard hobby farming as we would describe a lot of what happens in smaller rural communities where people have jobs off the farm as well. This is people farming for a living. The very important agricultural region, very important water resource use region, if you're trying to understand water in the Colorado River Basin, here's their water use, and it's a little more subtle there, but their water use from their peak in 2003 is down, about 15–20%. That black line is their inflation-adjusted crop revenue. Crop revenue is going up. The farmers are making more money, even as they're using less water. Their water use per their economic benefit per unit of water is going up. So these kind of adaptive behaviors are not only seen in municipalities, but they're also seen in the farm sector. And the farmers who are still in business are smart. They realize that there's pressure on their water supply. They've switched. This is an onion field in Imperial Valley. There's a lot of crop. They're using their scarce water on the more high-dollar crops. This is onions. The winter vegetable market is very big. A lot of carrots, a lot of lettuce coming out of Imperial and also Yuma across the river. And the result is that despite the rhetoric that you hear about our sort of doom with the California drought, California agricultural water use has been declining for 35 years. It peaked in 1980 and has been steadily declining. And one of the things that's happening is they're applying less water per acre. And the other thing that's happening is crop shifting. So, California, I don't want to get into the Central Valley, and California has some serious issues about overuse of groundwater in the Central Valley and the long-term trajectory of agriculture in those communities. They still have some issues, but I don't think we should, I think we need to not miss the fact that California agriculture, and this is true across the nation, is becoming steadily more efficient in its use of water, and that provides really important opportunities to continue to use water there and to also respect the integrity, the sort of long-term integrity of those communities that depend on water. We don't have to just say, well, we don't have enough water, there's no way we can have an Imperial Valley farming community. Those people are doing their part to reduce their water use in a way that sort of helps us all get by with less water. So this is great. All this progress is happening, and I get to this point in discussions of this frequently, and especially one of my friends who loves to beat up on me on this is, okay, yeah, that's really great, but Lake Mead is still dropping. And just a refresher on the geography, Lake Mead is the reservoir right near Las Vegas on the Arizona-Nevada border that holds all the water used in central Arizona, Phoenix, Tucson area, and Imperial, and all the Colorado River water used in Los Angeles, vitally important resource. It keeps dropping, and so while we have had significant success, and that's really important to enabling progress, we still haven't done enough. We are still using too much water in these communities relative to what nature provides, and if you look at the long-term outlook, and this is a slide from my friends at the Central Arizona Project a couple of years ago, the paper allocations of water from the Colorado River are still larger than that which nature provides. And the lingo for this is they call it the structural deficit. And it means that absent further action, Lake Mead keeps dropping to dangerously low levels where we're just going to have to make drastic cuts if we don't do something sooner. So I'm talking about success stories, but I don't want to gloss over the fact that we still have significant problems. So what does that mean we have to do? How do we get beyond the rhetoric of Cadillac Desert? I love that picture on the cover because that's a picture that says we're doomed, we're running out of water and we're doomed. So what do? We adapt, and one of the central things that I've learned over the years in writing about water is that when people have less water, they use less water. We have enormous abilities in individual ways and in community ways to use a lot less water than we are even now. The question is, where does that adaptive capacity come from? How can we sort of nurture it? And the most important thing right now, as we watch Lake Mead drop further, is how can we scale it up? We need, obviously, to do more of the kind of things that I'm talking about. My faculty appointment here at the University of New Mexico is in the Department of Economics. I'm not an economist myself, but I hang around with them a lot. And they talk about scarcity signals. And in a traditional resource market based on a capitalist model, the scarcity signal is really obvious. The price of gasoline goes up. The price is your scarcity signal. When the price goes up, you use less of it. We don't manage water that way for a variety of reasons, and we could go into a long argument about whether we ought to, but the fact is we don't. So we need to think about other scarcity signals that really will help us understand the need for changed behaviors and changed institutions. And I love the picture of Lake Mead and the bathtub ring. Journalists like me use this all the time because it's difficult to visually demonstrate the lack of water. And one of the things journalists often do is use the cracked mud photo, right? You've seen that a million times. Or the picture of Lake Mead. We need as communities to recognize that scarcity is an issue. But one of the really important things is we need to not be tricked by that orange line. We need to not be tricked into thinking that continued population growth, continued economic growth inevitably means a need for more water. And I think this is a way in which the Bureau of Reclamation staff who worked on this did just an admirable service in publishing this graph, and they were providing for us a baseline for thinking about it. People have interpreted this with this sort of sense of inevitability. And so I think it's really important to look at what's actually happened. And unfortunately for me, they changed the colors, but this is the most recent version of the graph. And you can see that yellow line, the orange line is now yellow, instead of continuing upward in an inevitable trajectory, has declined, has bent back down. And so what's happened in the Colorado River Basin is that humans, in fact, in response to scarcity, are using less water. The fact that Lake Mead is dropping means we aren't doing enough of it, but we're doing a lot of it. And if we're going to talk about our future, we need the conversation to recognize the fact that this has happened and look at how that happened and what we've done to succeed. And importantly, if we don't need to be on that orange line, if we realize that we can be on a line that's bending down, the pressure for, the pressure that forces us to think about risks of conflict becomes a lot less, and it gives us a lot more room to work together to negotiate these collaborative water sharing solutions that I talk about in my book. So I want to go back now to the bottom of the Colorado River and that day when Alyssa's Subaru was parked under the San Luis Bridge. And this was, a day that really sort of changed me in terms of what I was doing and how I was approaching this book. About 2 days before this picture was taken, upstream about 20 miles, the International Boundary and Water Commission, the sort of joint U.S.-Mexican agency that manages Morelos Dam, that dam that I was standing before in the picture Michael showed you, they began releasing water down the channel of the Colorado River, down this dry river channel. And on March 25th, I went there to see what was going on. This picture was taken around noon, 11 a.m. or noon on that day. As the water arrived by perhaps 4:30 in the afternoon, this is the scene. This is that same scene. I had to move the car as the water arrived. And an interesting thing happened. And I had viewed the pulse flow, the release of water for this environmental experiment as an environmental issue. And I had arranged visits and meetings with environmental scientists to tour their environmental sites and learn about this as an environmental project. This was a joint U.S.-Mexican project that in the midst of a relatively deep drought carved out some water for an environmental experiment. But what happened in the city of San Luis, if you see all those people who came out when the water arrived, this is a city, the name of the city, residents explained to me more than once, is not just San Luis, it's San Luis Rio, Colorado. This is a community that has the name Colorado River That's part of its name. They're really proud of the fact they're the only city that has that. But as you can see in that picture in the top left, they don't have a river. It's a city named after a river that has been taken away from them. And so the community response to having their river returned was really profound. And I really changed my journalistic plans and spent a bunch of time hanging out here at the San Luis Bridge trying to capture the story of a community getting its river back. And so this is really important because what it suggests is that as we do these things that allow us to sustain the cities and the farms in the West, as our values change and we decide that things like this, environmental flows for the communities that live on the banks of rivers matter too, we have the space, if we're willing to use it, to collaboratively and cooperatively share the values of water more broadly. And, I mean, one of the things, I talk mostly about cities and how cities are not going to die, and farms are not going to die. But what this provides for us also is this opportunity to look at how we use and value water more broadly. And if we care enough about doing things like this, to return water to communities and the environment. And so ultimately, what I want to offer here is an alternative narrative. I want to tell stories, because I'm a storyteller by profession. I hope they are rooted in sound science and policy, about an alternative path for the future that's not about the sort of doom and gloom that the sort of persistence of the Cadillac Desert drooping tree doomed communities would suggest. I am really hopeful about the opportunities that we have going forward. I would like to thank a ton of people. I'd especially like to thank the University of New Mexico, which when I quit newspaper work to work on the book gave me a home to work on the book and some students to work with to pique my curiosity, as those of you who are academics will know that does. The University of New Mexico Water Resources Program has been a fabulous home for me. I somehow stumbled into becoming its director last year. So now I have the chance to really work closely with students, and I'm really enjoying that. A bunch of people who helped me, especially my editor, Emily Turner Davis at Island Press, who really helped shape these ideas. And that guy in the top left, this guy named Juan Hernandez, who when I was trying to find my way around San Luis and the River Channel, became my guide and showed me a part of the river that I would never have gotten to see, and showed me how a community really can embrace the return of its river. So with that, we have time for some questions. Michael?
Great. John, I want to thank you very much. And I also want to say that it was really quite a pleasant surprise to me that the University of New Mexico hired you to direct the program. And you're going to do great things for it. Got a number of questions, also a number of comments who a number of people just wanted to comment you for an excellent presentation and encouraged the viewers to actually read the book, because there's obviously a lot more information in there. I do want to announce that you have set a record with our webinar. You have 434 registrants, so in keeping with our contract, we will double your speaking fee, so don't worry about that. The first question is, isn't the Colorado River supplying less and less of California's total water supply? That's from Tom Biastetto.
Yeah, it is. In fact, one of the things that happened. There's actually a couple of chapters of this in my book. In 2003, there was a sort of complicated fighting/negotiated collaborative agreement that reduced California's take on the Colorado River. California used to get sort of by default, whenever there was extra water in the river, more than 5 million acre-feet. Southern California had really come to depend on that extra water. A series of agreements, both negotiated and some sort of federal government kind of stepped in and threw some elbows, reduced Southern California's take to 4.4 million acre-feet from the 5+ million acre-feet it typically took, up through the early 2000s. And I think one of the really interesting adaptive stories, and I spend a lot of time on this in my book, is the way Southern California responded, the Metropolitan Water District of Southern California and its the municipal water providers. MET's a wholesaler and provides to municipal water suppliers, how they adapted successfully through things like development of local supplies, through conservation, through some really innovative storage agreements, through agreements with agricultural water users, especially in the agreement between San Diego and the Imperial Irrigation District. So that adaptive story of Southern California, which is a very successful story, is a really important piece of the examples of how this kind of stuff can be done. Yeah.
Okay. Next question, kind of short and sweet from Julian Reyes. Is groundwater usage considered a more adaptive, and that's in quotes, form of management when surface water withdrawals aren't enough for farmers?
You know, that's an interesting question, and I'm gonna punt a little bit on it because in California's Central Valley is a complicated story, and I don't know it well enough. In Southern California, we have seen a really move away from the stabilization of aquifers and a move away from it, but it was also a move away from agriculture. In Central Arizona, also a move away from groundwater for agriculture to the use of surface water. So the folks doing those things decided that it was more sustainable to stop overpumping their aquifers and to use surface water instead. One of the things that you're seeing increasingly in these communities, though, and this is more of a phenomenon with the urban water users, is that they're beginning to look at their aquifers as storage systems and then pumping them up and down. Albuquerque's water resources management strategy looks at that as a strategy. You see this in parts of Southern California especially, so that in that way the aquifer becomes a sort of resilience tool. It provides some resilience when surface water is scarce. You pump groundwater. When surface water is more plentiful, you recharge aquifers and do it that way. So I think that kind of circles around the question, but I hope that answers it.
Okay. Circling is okay. That's fine.
Yeah.
Matt Denniston would like to know, while conservation gains are impressive in desert communities, isn't it more even-handed to look at water consumption per capita? You do this in your book a little. Las Vegas is around 200 gallons per capita per day, whereas I saw that in the San Francisco Bay Area, it's close to 50 gallons per capita per day. So,
yeah. So I mean, there's a reason that I spend a lot of time on the total use because when communities want to grow, it's the total use that matters, and you can have a per capita reduction, but if your population growth outstrips it, then you're still using more water. I think both are important. One of the things that's maddeningly difficult is comparing per capita water use across communities, because for two reasons. First of all, the way it gets calculated varies from community to community. We don't have standardized methodologies for calculating per capita water use. But the second is communities are different. So if you're in Las Vegas, you only get 4 inches of rain a year. You want to have a yard, you're going to water more. And so water use is naturally going to be higher for a given set of sort of community amenities. And so comparisons are tricky. In general, per capita water use is going down everywhere, partly just through the Energy Policy Act of 1992 mandated lower flow toilets, and as a result, every new toilet uses less water than the old ones, shower heads, faucets, etc. And partly through policy initiatives in communities, and so per capita water use is going down everywhere. I mean, I think ideally, with enough time and nuance, you really need to be looking at both. And with enough time and nuance, it's important to look at different communities. So Las Vegas, for example, I describe as a success story. They're still up around 200 gallons per capita per day. They still have a lot of room to save more, and that's one of the things I argue in my book is when push comes to shove, their numbers will go down more and more. They still have a lot of room to conserve. Communities like Phoenix, my own community of Albuquerque, very successful in conservation. I think we still have a lot more room to go.
John, that the use of Las Vegas kind of brings up a question. When they talk about per capita use, what do they do about the fact that it's essentially, a big tourist draw, and then you have, a gazillion tourists a year? Are things adjusted for that, or do they try to adjust?
No, and this is one of the difficulties in measuring per capita use is, different sectors of your economy use water in different ways, and so Las Vegas has a big tourist economy that's using a lot of water. That shows up in the numerator of your gallons per capita per day calculation, but not in the denominator of your population. And that's one of the things that makes comparison really difficult. Communities that are just residential are going to use less than if they have a computer chip fabrication plant or giant resort hotel casinos. Or, and this is trickier, farms. Farms use a lot of water. Do you count that in a community's gallons per capita per day? I mean, we don't, but it's their economy. Maybe we should. I don't know. I mean, I think it's important not to expect us to get one single answer out of GPCD, but to sort of discuss all those issues when we talk about the GPCD calculations.
Okay, that's good. Excuse me. Let's see. Boy, coming in. From Jim Gross. Your data suggests a societal capacity to stabilize water use at some particular level. However, the level of stabilization in nearly all cases is such that extensive ecological damage has already occurred. Are there any lessons learned that might suggest might be able to stabilize water use at levels with lesser ecological damage?
I think the answer is yes and no. There are a lot of lessons where the answer is no, where people have chosen to just use their water and ignore the ecological damage. And this is a political and policy and values debate, right? These are humans that are going to make those decisions. But there are a lot of examples of places that have sort of shifted their policies to start to include the environment in their decision making and to take some of this saved water and use it for flows in the rivers themselves. And the most interesting place, and a place where I've been spending a lot of time lately, is the state of Colorado, where you have government decision-making entities. They're called Basin roundtables that they've set up in Colorado, where under state law, and these are entities that make financial resource allocation decisions for water management, capital spending, that include by legal design and representatives in the environmental community and the recreation community is a very important part of this in general, but especially in the state of Colorado, fishing and rafting and skiing and all that. Those environmental flows in the state of Colorado are part of the discourse. It doesn't mean they always get the water, but they're included in the decision-making process as environmental values matter, and politicians ignore them at their peril in the state of Colorado. That's an example of success. There's a really interesting discussion right now over the San Pedro River in Arizona. I don't know what the outcome is going to be, but environmental interests are, at the table and trying to gain traction with their view that water should remain in this beautiful desert river, the San Pedro. So there are places where it's happening, places where it won't. I guess my argument is that the kind of decoupling that I talk about makes that discussion possible, and we need to recognize that it's possible to have that discussion. And then it's up to communities to decide if that's the thing that they value and want to do.
Okay. Here's a question from an unknown registrant here, and that person would like to know, your book's been out now, since about September 1st or something like that, and they're wondering, has any foreign organizations or foreign entities contacted you about coming and making a presentation, or has it been strictly pretty much domestic?
It's been pretty strictly domestic and pretty much in the western United States. My story is about the arid Southwest. It's it's a story that very much I think applies in a lot of places. But no, I haven't been. That's interesting. That'd be cool.
Okay. Well, you still have a lot of time left.
Yeah.
Okay. Do you think tribal reservations in the Colorado River Basin will ever take their full appropriation, and what impact could that have on junior downstream appropriators? That's from Tim Wick.
Yeah, this is a great question. There's a whole, buy the book, Tim. There's a whole chapter on this. One of the, we don't know the answer to that. One of the shortcomings of the collaborative decision-making processes that I talk about in my book, this gets a chapter, and a lot of it is devoted to Indian water rights, is in these collaborative decision-making processes, who is included and who is left out. Really importantly, Native communities have been largely left out for most of more than, more than a century that we've been engaged in this project of the development of water in the Colorado River Basin. Increasingly, they're starting to be included. We haven't done that well, and we have to do that because they have these legal entitlements to water that are often not being met. That will have an impact. One of the things that happens when we do move forward on these is sometimes really useful collaborative agreements about the use of that water that provides water for Indian communities, that provides infrastructure for Native American communities, which were largely left out of the federally subsidized water infrastructure boom of the 20th century, in a way that meets their community water needs with perhaps less than what would otherwise be their legal entitlement. These are settlements, they're trade-offs. But yeah, there are a whole bunch of unquantified Indian Native American water rights. This is especially true here in New Mexico. We don't know what the impact of that will be on other users. It's another potential stress on an already stressed system, absolutely.
Okay. Oh, here's a short question from next month's presenter, Lara Fowler. What's your next book project?
Oh, I've got a couple. There's a really interesting project that I'm talking about with a friend of mine who's been looking at the science of our understanding of water in the Colorado River Basin, what we knew and when we knew it. Fascinating research. This is my friend Eric Kuhn up at the Colorado River District in California. He's done a lot of work on Colorado, the Colorado River District, the West Slope. He's done a lot of work on this really interesting project. And the other thing I'm poking around in is sort of the long-term future of agriculture in the arid Southwest. Where is this headed? You know, I wrote a book that captured a moment in time. And I really am fascinated by the agricultural landscapes, these working landscapes, and what's going to happen to them going forward. That was sort of the most interesting, the funnest part for me as a city kid, to really spend time better understanding these agricultural communities. Because I used to think, you know, that farming in the desert, growing lettuce or alfalfa in the desert was a nutty idea. I now think it actually makes a lot of sense, and I have a lot of respect for the people who do it. And I think there are enormous challenges in thinking about the role of agriculture going forward. So that's the other thing I'm thinking of. I don't know right now. I'm so busy dealing with the birthing of this book that I haven't had a lot of time to think about those projects.
Okay. Oh, here's a good question. John Wells, God bless you, John. If you could wave your wand and make the change, what would you change in the mix of state and local water laws and or their administration across the West? Boy.
So I'm not going to take that bait. And the reason, no, so
That's okay.
the reason is that, you know, one of the things that I spent time on, tried to really deeply understand as I was working on this book, was the nature of the processes that we have as we have them and how they can move forward. So I could come up with a list of a bunch of things, but wand waving doesn't work. You know, we could, and you know, the closest I have to wand making is what I'm trying to do in the book, which is help people understand that these, given the legal framework that we're stuck with, these collaborative, that this decoupling makes a lot possible, that adaptive capacity is there, and that these collaborative arrangements are the way to work forward. So sort of any sort of wand waving, I mean, I could say, you know, abolish prior appropriation. Well, I don't think that's a good idea. I could say rewrite the Colorado River Compact. I don't think that's a good idea. I mean, all these things have such downsides that I think the path forward is building within the structures we have. And so, yeah, so I'm sorry to punt on that question, but I just really, that's where I'm at.
No, that's okay. That's okay. You can punt. You can't punt on this one. Tony Willardson out there in the Salt Lake Valley. Can you address the Salton Sea issues?
Yeah,
25 minutes or less. Yeah.
Yeah, exactly. So for those who don't know, the Salton Sea is this sort of giant inland lake, was formed in 1905, 6, 7, when the Colorado River kind of jumped its banks and took a right turn and filled this sort of inland basin. It has since been sustained by agricultural runoff in this sort of rough equilibrium, runoff and evaporation. It's increasingly an environmental problem because as we succeed in using less water in Imperial, there's less runoff, more evaporation, the sea shrinks, and the exposed shoreline is a source of toxic dust. Really high childhood asthma problems in Imperial and relatively poor communities. So it's a really important environmental public health and really environmental justice issue. And for a long time, as I was working on the book, I joked to my friends who work on the Salton Sea issues about my efforts to leave it out of the book because it's such a complicated problem. I failed, as you'll see in the book. It's like in there, I think, 3 different places. It's a very complicated problem, but I think really importantly, I wrote an op-ed for Christmas that ran in Sacramento Bee, that the state of California really has an obligation to kind of step in and deal with some engineering solutions that will prevent some of this environmental damage and public health risk as the Salton Sea shrinks and as the agricultural runoff declines with water conservation. This is a commitment, I think, arguably, that the state of California, the citizens of the state as a whole, took back in 2003 when the deals were negotiated to reduce California's use of Colorado River water. The agricultural users, the farmers in the Salton Sea, in the Imperial Valley, have done their part. They've reduced their water in a very successful way that's really helped California as a whole deal more flexibly with its water problems. The state has not kept up its end of that bargain. And so I really think there's a really important obligation on the part of the state of California. The state as a whole has benefited. It can't just impose the burdens on the communities of Imperial because of this public health issue.
Okay, I don't know if I should ask the next question. This has kind of opened up the gates here. Can you solve the California Bay Delta issues?
So you notice when Laura asked her question about my next book, I didn't say the Bay Delta. I've actually toyed with a book about I've actually toyed with a book about the Bay Delta too, and spent some time thinking about it. The Bay Delta problem, Sacramento Bay Delta problem, I don't understand how it gets solved, and it's an alternative pessimistic narrative right now. I'm not sure I see the path forward. Okay. And so I'm kind of, I don't know. It's a tough problem.
Okay. Here's a question. Oh, okay. I think this might be a little more answerable. Wondering how much of the reductions in water use shown can be attributed to adaptations like conservation versus shifts from water-intensive agriculture land use for comparatively more water-conservative uses associated with urbanization and development. Is this a sign that we are pushing the water-intensive practices outside our borders? Or
so let's unpack that question. First of all, the last part, are we pushing water-intensive practices outside their borders? There's some data, in other words, are we conserving water here, but they're just using some water to make a product in Asia? There's some data that suggests that's probably not the case, that is not happening, so it's not just shifting water use outside the United States. If you look at the conservation trends can be found in both municipal sectors and agricultural sectors separately. This is really geographically complicated. If you go to a place like central Arizona, one of the ways they've successfully used less water overall is urbanization, where cities have been built where farms once were, and the cities use less water. But in general, cities are using less water and farms are using less water in the places where the farms have persisted, in places like Yuma and Imperial. So there are exceptions, but in general, conservation holds in all the sectors, industrial sectors, municipal sectors, and agricultural sectors.
Okay. Next one's from Nea Subramaniam. Okay, John, you mentioned that the aquifer near your house in New Mexico saw high levels of recovery even during a period of drought. You attributed that to changing behaviors, I assume conservation and efficiency, and also the use of imported water. Aside from increasing the health of the aquifer during drought, is it really fair to consider this recovery a local win in terms of usage? The way I see it, the community is still diverting or importing water from somewhere else to meet its demands.
Yeah, we're doing that. I would agree, and that's a value question. We made this decision to build cities based on water exported from the Colorado River Basin. That's a value question. I happen to like living here. I've lived in all these places that do this, so it would be pretty hypocritical of me to say that that's wrong, right? Because that's how I've chosen to live my life, and the communities that I live in have chosen to behave. But we we did not increase our exports to do that. We were exporting that water all along. We have been exporting that water since the 1970s. So we did not increase our imports of water from the Colorado River Basin to do this. We were just using them for other things, and now we're using them to provide our drinking water.
Okay. Let's see. Boy, we've got some water rights questions here. Oh, water flows to money. That's good. This is just an observation, actually from a friend of mine who lives up in the land of Francis Newlands, the Newlands Project out east of Reno, and on Mayan, and he said that the Reno area, I guess maybe Washoe County, made a significant reduction in their agriculture use of water in the Newlands Project simply by making purchases of water rights and sometimes land, essentially, giving them money they couldn't refuse. So he just wanted to kind of mention that. It's not asking for a question, but in that case, water did flow to money. And there's actually another water flow to money, Daniel Van Abs. I'm combining these two. I've always seen water runs uphill to money, not as an invitation to theft, like the Owens Valley situation is a cautionary tale, but that the rich can afford and pay others for water rights. They will do this whenever water is available, water is needed, and the price is right. So how might that play out?
So one of the things that is happening now is trying to figure out mechanisms for doing that. But one of the interesting things that's happened in a lot of these agricultural communities is an attempt to set up these mechanisms in a way that preserve the agricultural community. So they're just not selling all their water. They're saying, we'll put limits on how much water can be sold in a way that continues to preserve the core of our farming communities that we value. It's, the phrase buy and dry, which is where you just buy up a bunch of agricultural land, dry it, move the water to the city, has really become kind of a swear word in the Colorado River Basin. People have really decided buy and dry is a bad idea. So what we end up with is these much more collaborative arrangements where, in fact, the wealthy communities do spend some money, buy some water, pay for farm system efficiency improvements, which you're seeing in Imperial and also in Mexico right now, and doing it in a way that that preserves the integrity of these agricultural communities. And I think that's where the future is. So yeah, I mean, there are cases where water does flow uphill to money, but in much more subtle and complicated ways, based on the idea that the rich people just can't come in and take it from these less affluent agricultural communities.
Okay, this one's from Bert Griggs. Great presentation, John. How much of the successes in the Colorado River Basin have to do with effective federal control over Lakes Mead and Powell? Does your optimism presume a strong and effective federal presence? Other basins are much less federalized. Thank you, Bert Griggs.
Yeah, actually, I think the answer is no. And I kind of spend some time on this in the book, but the federal government's approach to water management in the Colorado River Basin has really been to be not an enforcer. So it's not a top-down, the federal government saying thou shalt, although that has happened in a handful of cases and issues. But in general, the federal government as a convener to create the necessary framework for the water-using community, the states and the big water users within the states, to negotiate solutions collaboratively. So the federal government has not, I mean, there are people who argue the federal government has a lot more power. There's a lot of legal ambiguity about the federal government's power in the Colorado River Basin. But rather than the federal government having a heavy hand, it's been a more, in the sort of political scientist notion of federalism, where you have a distribution of powers with a lot of power remaining at the state and local level. It's been to create these collaborative negotiated frameworks with the federal government kind of as a convener and instigator, using its powers to do that rather than to impose solutions.
Okay. This next one might be a little bit outside your wheelhouse. I don't think Peter Glick's on the call. Do you know the primary causes for the flatlining of U.S. water withdrawal starting about 1980? That's from Muhammad Khan.
Yeah, there's a whole bunch of things that go into that line. There is municipal efficiency and technology. There is changes in agricultural practice. Those are the two most important factors. So those are the major, and I'm pretty sure when Peter drew that line, he didn't include hydroelectric cooling water.
Right.
When people are doing these numbers, sometimes, thermoelectric, I'm sorry, thermoelectric cooling water. People do it both ways. You see the curve bend down in either ways, but since the thermoelectric is not consumptive, is a diversion, but is not totally consumptive. But yeah, so it's basically increased agricultural efficiency and increased efficiency in municipalities, but then there's a gazillion things happening below that, changes in irrigation technology, changes in cropping patterns and water use and cropping patterns on the agricultural side, and in the municipal side, both policies that changed outdoor, policies and value changes in communities toward outdoor watering, and also technological changes inside the homes, low flow toilets and shower heads, et cetera.
Okay. You hanging in there? I've got three more to go. Okay. Okay. We still have 165 people on the call, which is pretty remarkable. Yeah. Okay. Another one from Jim Gross. Studies in Florida have demonstrated that public water supply demand is partially elastic to price. Yes. Okay. Neither very low income nor very high income users exhibit much elasticity to price, but a large segment of middle income users will moderate their demand as a function of price. Has that phenomenon been observed in the West?
Yeah, absolutely. Absolutely. And this is one of the things that my economist friends like to point out, is that given that phenomenon, the fact that government agencies tend to underprice water means they haven't used the most effective tool in their toolkit yet. Water is still really cheap municipally, and that if and when they need to, raising prices is an option because of the change in behavior that's described by that sort of elasticity and elasticity relationship. Yeah.
Okay. Okay. Do you consider the balance between the compacts on the Colorado River versus the Rio Grande, Rio Concho?
I don't talk about the Rio Grande, the Rio Grande system in New Mexico, Colorado, New Mexico, and Texas, and Mexico at all in my book. I don't look at those. I don't have a lot of expertise in the way the treaty is implemented there. The compacts and the treaties are implemented in the relationship. Sorry.
Okay. Here we go. I was surprised to hear you say that by increasing efficiency, farmers have been able to avoid restrictions in water allocations. In my view, all Western water users have been drawing the water banked in the Colorado River reservoirs. Note that declining water levels, in Lake Mead, and is it realistic to assume that Western water users will stabilize the water level in Lake Mead before it falls below the intakes on Hoover Dam, with drastic effects on all users, plus the result that power generation ceases? John Herbert.
Yeah, I think they're going to do that. I mean, I'm one of the things I spend a lot of time on now in my journalistic / whatever life, academic life, is look at those processes, the discussions that are underway, the policy initiatives that are underway now. Those are really serious discussions based on the premise that everybody agrees that has to happen. They're difficult discussions. This is the discussion of what's called a drought contingency plan, which is further reductions on water use to prevent the sort of doom scenario of Mead dropping to dead pool. I think they're going to do it. I'm optimistic. There's a lot of serious initiatives on the table and a lot of workable solutions that are out there, and a realization that the outcome of that dire scenario would be unacceptable, and that that these continuing down this path of water use reduction is really our only option. So I'm optimistic. Yeah, tough stuff, but I'm optimistic.
Okay. Actually, one more came in, so this is it, John. You'll be done. You have not mentioned contingent water transfers, the case where urban areas can move water only under specific conditions, usually drought. The urban area has an assured water supply, and the area continues production in most years. It does not allow for permanent crops, but forage and annual crops can continue. Any thoughts?
Yeah, this is one of the experiments, and I only talk about this a little bit in the book. I'm kind of regretting not including Palo Verde Irrigation District more, which is an irrigation district around Blythe, California, where they have these kind of dry year fallowing agreements where farmers get a revenue stream that essentially the cities are kind of buying a water easement, and the farmer farms, and then in a year where it's really dry and they need the water, they put in the call, the acreage gets fallowed, and the water is moved to the city. This has been one of the models that people view as a very successful model. And I think, there's a lot of evolution of that policy and some concerns in Palo Verde right now about the long-term direction farming there is headed. I know that's one of the areas where I'm spending time thinking about my next book is how Palo Verde evolves. So this is one. There's a whole bunch of different kinds of specific policy mechanisms like that, deficit irrigation, dry year fallowing agreements that just have to be sort of negotiated on a case-by-case basis with sort of each individual community thinking what's going to work best for them. But that's definitely one of the ones that's shown success.
Great. Yeah. Okay. And that was from Noel Golahan, who's an economist, by the way. So that's it. Still have 145 people listening, and it's now 20 minutes past the hour. We're going to let you go. And John, I just want to thank you. I'm sure the people out there are applauding. I got a number of people. My colleague Aaron Wolf said, "Great job, John. Wonderful book." And I don't want to sound like a shill, but folks, you should read the book because there's a lot more.
No, do sound like a shill. You have my permission, Michael.
Okay. Then I'll expect the same amount that we're paying you in return. But I'd also encourage you to read John's blog. It's at if you can just Google John Fleck, J Fleck at inkstain.net. I think it's one of the smartest water and environmental blogs that I've come across. I mean, there's a lot of analysis, and you wouldn't know the guy who's writing the material has a degree in philosophy. You'd think he was an engineer or an atmospheric scientist or something. It's absolutely amazing. You can also follow him on Twitter at simply @jfleck, F-L-E-C-K, and you'll be amazed. He's all over the map, and he's always spot on. So, okay, my shilling days are now over. Okay. So,
thanks. Your check's in the mail, Michael.
Right now, yeah, I'm gonna use PayPal to get it out to you. So anyway, Christine, if you could maybe the thing back to me, the powers that be. I just want to remind people of the next couple of webinars. Show my screen. Okay, there we go. Oh, that's a wonderful screen. Okay, let me. We actually had Lara Fowler ask a question about your next project. So next month we can turn the tables on her and ask her questions like that. And we're going to be switching to the East Coast. And I know there are a bunch of Easterners on the call today. And when I mentioned the Bay Delta, it was probably, what is that? But we're going to get into regulated riparianism. Then we go to sediment monitoring in March, a little more technical. And then as John mentioned, Bill and Rosemary are going to promote their book. And like John, I read the galley proofs and the proposal and everything. And this is, I don't want to say for the intelligent layperson, because I'm not sure there are too many of those around, but this is a book for the people who aren't groundwater specialists. And Bill and Rosemary lay it out like no one has ever laid it out with respect to groundwater. So this is going to be great. And actually, that's going to be a great lead-in to Sharon Megdal's May 17th webinar on groundwater governance and management. And then we'll go full circle. We'll come back to Sarah Porterfield from UC Boulder talking about the American Nile. And again, if you have any suggestions, send me an email at aquedoc@awra.org for webinars, and we can get on it because a couple of them came in just that route. Sarah's did, as well as Molly Woods. So I'm signing off. I'll talk to you again in, actually, I think it's 4 weeks from today. John, I just want to thank you again. This was all I thought it would be and a lot more. And I'm using your book in my water management class. So anyway, everybody else, thanks a lot for participating. Hope you have a great rest of the day, a good weekend, and a good year. So signing off. Bye.